All right, guys, this is coming from our new school. Our first lesson is actually going to be taught through a video. And I talked to you guys on Thursday. We're looking at solving systems of equations algebraically. And we actually finished our last problem of the day, our word problem, through solving it algebraically. The numbers were too large to put on a graph, so we solved it using our substitution method. There are two methods to solve it algebraically. One is substitution, and the other one is elimination. And these are two methods that you should have used in Algebra 1, but we're going to go over a couple examples and how to use each of these. All right, we have two equations here. Our first system of equations we're going to solve using substitution. And the key with substitution is when you take a look at the equations, is there a variable that you can easily solve for? And when I say solve for, it doesn't mean numerically. Are you going to get an actual number or value for the variable? But it means, can you isolate it, get it by itself, and which variable is the easiest to solve for? Can you solve for x in the first equation? Yes, but we'd have to divide everything by 2 to get x by itself, which would create fractions. So y is actually easier for us to solve for in this problem. Subtract 2x from both sides, and we have solved for y. Y equals negative 2x plus 5. Now that we know the value of y, we can substitute it in the second equation. Always plug it into a different equation, never the same. We can never solve an equation that has two variables. So now that we know the value of y, we can substitute it in, and we'll have just values of x. So x minus parentheses, negative 2x plus 5 equals 1. I always say put parentheses around values that you're plugging into an equation, especially here, because now we're distributing a negative 1. X plus 2x minus 5 equals 1 is our equation that we're going to solve for x now. So 3x equals 6, and then x equals 2. Now that we know the value of 2, we can plug this value of 2 in to our first equation, our second equation, or even the equation that we have solved for y. Y equals negative 2 times 2 plus 5. Y equals negative 4 plus 5. Y is equal to 1. But what is this solution? We worked on this in 3.1. If we were to graph this, what does the solution look like? It's our point of intersection. So be able to write your answer as a coordinate. And 2, 1 is our answer. Again, to check to see, is this a solution, we can plug 2, 1 into both of these equations. If I plug it into the first one, 2 times 2 is 4, plus 1 equals 5. That one works. 2 minus 1 equals 1. So 2, 1 is a solution for this system. All right, our second problem we're going to solve using elimination. And with elimination, we're going to be adding the two equations vertically, straight down. And our goal is to get values of x or y opposite. So when we add them up, they become 0, and we're not left with that variable in the equation any longer, and we'll only have one variable left. So if we take a look at these two equations, 3x minus y equals 12, 5x plus 2y equals 20. Currently, if we add these vertically, 3 and 5 give us 8x, negative y and 2y give us 1y. So neither of the variables would be canceled out right now. So which equation do we want to change so that if we add them, they add up to 0, and that would be our first equation. So this top equation would have to be multiplied by 2. And I like to rewrite both equations. So if my first equation now is 6x minus 2y equals 24, and I'm still going to rewrite my second, 5x plus 2y equals 20. Now if I take a look at our y values, we have negative 2y, positive 2y. If we add these up, 11x, negative 2y, positive 2y, those will cancel out, equals 44. And when we solve for x, x is 4. We can take our value of 4, go back to either of the two original problems to plug 4 in. I'll just take the second equation. We get 5 times 4 plus 2y equals 20. 20 plus 2y equals 20. And we get that y is equal to 0. And again, if we were to graph these are two lines. Our solution is a coordinate. And so yes, our answer needs to be written as a coordinate. That's what the solution would look like on a graph, and that's what it should be even if we solve it algebraically. Okay, in our last example, there are some system of equations that you'll be asked to solve using any method of your choice. So a problem like that, we need to kind of analyze the equations that are given to us. Substitution. Is it easy for us to get a variable by itself, solve? Or elimination. Can we easily add two variables and have them equal 0? If we take a look at the equations we have, to solve for x, I'd have to divide by 7, which would create fractions. To solve for y, I have to divide by 2, which creates fractions. To solve for x in our second equation and y in our second equation would both cause us to have fractions throughout the problem. So substitution is probably not the best method. Elimination is probably going to be our choice for this problem. Now, what variable is going to be the easier of the two to eliminate? So we have 7x and 4x. So think about what is your common multiple between 7 and 4, and that would be 28. So it's fairly large. And then 2y and 3y. The common multiple is 6, so it's much smaller. And I like y better than x because they are already opposites. Positive 2y, negative 3y. So they're already opposites. So I already know that my y needs to become 6y and negative 6y. So both equations will have to be changed. The top one, we're going to multiply by 3. And the bottom equation, we're going to multiply by 2. So sometimes I draw arrows down to help me follow where my equation came from. 21x plus 6y equals negative 3. And 8x minus 6y equals negative 26. And now we're set up to add these two. So we get 29x. The y values add up to 0 equals negative 29. So x equals negative 1. And so we get x equals negative 1. And we can plug negative 1 into either of our two equations. Maybe I'll choose this bottom equation just because 4 is smaller than 7. So 4 times negative 1. Add 4 to both sides. And y equals positive 3. So negative 1. Positive 3 is our answer. So again, you're going to have problems that tell you to use substitution, tell you to use elimination, and then some problems that give you the option. And again, look at, is it easy to solve for a variable, or is it easier to get two variables opposite so you can use elimination? Check out the other Khan Academy videos that I'll be posting underneath this one as well.